Hello everyone. Today the lecture topic is the masonry. What is about the masonry? The masonry usually made by the modular material. What is about the modular material? It can be the brick or it can be stone. So I covered the masonry material this semester and next semester. So this semester is more to introducing about the more fundamental idea to understanding about this masonry material. And next semester, we more to talk about how you assemble, what kind of assemblies you might consider for the project. So today we more to discuss about the different materiality using the masonry material. So when you see this first cover image, it is the Columba Museum designed by Peter Junter. So you can find the various brick assemblages on this elevation. You can see the existing the Gothic church, using the stone, the masonry construction, and also you can see the brick assemblage. Also you can find this preparation method. We talk about how you consider and how you using these types of the construction for your design. What about the brick? The brick is the atypical assembly type for these days. You can find these brick everywhere, especially our campus have a lot of a brick building, and people usually don't fascinating about the brick material a lot because you can see this typical method over and over. But however, nowadays, architects consider this brick material differently and manipulating this brick material differently to design their own facade system using these modular materials. So first one, let's see this modern classic building. It is the Alba Aalto house. The Alba Aalto, the renowned architect in Finland. So when you see the courtyard here, so his house, he testing out the lots of a different assembly in his courtyard. It has more than 50 different brick assemblies which are arranged in a various pattern. Alba Aalto tests the aesthetic of different arrangement while monitoring how they react in the rough climate. So Finland is very cold, so he testing it out depending on this combination of the brick, how these assemblage persist in this severe weather, and also he testing out the different aesthetic of the building assemblage. And when he like about it, he actually using these pattern to the actual his project. So next example, it is the Genie Gang, the studio gang in the Chicago. The project name is the Brick Weave House. So architect more to carefully assemble this brick rather than conventional the stacking method. When you see project here, you see this conventional the brick assemblage method, but this front yard, they designing this screen using this brick perforated assemblage. From this region, the building has the more unique because the more private part is more of the living area, made by the solid brick assemblage method, and then this is more about the public way. But architect proposed more the neutral space between the public and the private. It is more about the blurred zone between the public and private. So that's why he designing about the front yard space using this screen. It means still he keeping the privacy, but still he keeping some more outdoor feeling, and also it is kind of giving the lots of interesting lighting diffusing from the outside to inside or inside to the outside. So from the outside you can see this beautiful the patternized brick assemblage, which is you can see the lots of preparation. This preparation is maxed out that this building more special. Nowadays the brick is using this preparation method because it is made by the modular base. It means the modular base material, it is easy to rotate and easy to make this preparation pattern. So this brick design is actually supported by the metal structure here. So you can see this is a metal structure, and then this brick is only works as a decoration. So nowadays brick is not actual structural material. It is more to using the decoration purpose. That's why it is available to making these types of the facade design. So we talk about this decoration purpose, the material, also structure purpose, the masonry later of this lecture. And this brick, even using some high-rise building, so you can see that they have some more conventional stacking method, the side, and then the middle to provide accent of the space. They're using the brick for they're using this perforated brick for the middle of the space. So this kind of perforated part giving the articulation of the building facade. Also, it provide more interesting the indoor quality, and also it is kind of giving the unique kind of elevation design using this modular based design. So from inside, you see through this perforation, lighting actually growing from the inside to the outside, and also during the daytime, the lighting actually diffuse from the outside inside to creating this beautiful, interesting the pattern to the space. So means you can just using this modular character of the brick, you can just create lots of different the pattern, lots of different impact over your building design. So you remember about the project I covered from the first slide. This is another example designed by the Peter Junter. The building located over the Gothic ruin. You can see this Gothic ruin church. This is a Gothic church destroyed in the World War I, and then it just lived as the ruin. But German, they decide to build a new museum construction over this existing the ruin, and then they hire the Peter Junter to designing about the new museum. The Peter Junter want to preserve this existing facade, and then he just want to respect this existing historical layer. So from this region, they choosing the brick to matching with the existing elevation, so which is the existing the building facade. So this is the existing building facade. This is existing the Gothic church ruin, and then the bottom brick actually adding the later after this Gothic church demolished it, because about they just have to be supporting the wall. So then this gray brick, they added it over the existing ruin. They just kind of choosing this brick method, and then to matching with the existing the building condition. Also, they also consider about the overall the cityscape. So they very carefully choosing this material to provide the unique the way to expressing about the architectural language. Also, they want to the respecting the existing the ruin condition. So using the perforated part, you can see that this is only decoration wall, and then this is supported by this metal structure. You can see that this metal structure here, and then lighting actually diffused from the outside inside. It's beautifully casting the lighting from the outside through this randomly open the brick perforation, and then this is also very well matching with the existing ruin, and this is a new construction here, and it is kind of beautifully touching each other, and how architect respecting the existing historical layer, and how architect capturizing the memory to the space through the new construction. That's a really good example to understanding how we consider about the material, and how you can choosing the material properly for the project. So next example is also very interesting. It is great example to use the local and historical material in this building. The project name is the Ningbo Museum, designed by the Wang Shu. The Wang Shu got a Pritzker Prize a few years ago, and then he considered using this local historical material to the contemporary and modern architecture. This is a very trend to use this local material, even when you're just kind of designing about your project in US. Every state has a typical and local material. So you consider to build in Santa Fe or you want to building the project in Chicago, or you want to building in the project in California, every state has a local material. But how using this local material as the new way? So means so local material can making your project more special because this local material is only find out the from this local site. So Wang shows more focusing on this aspect. That's why he using the more historical and local the masonry material for making out this building elevation. So when you see the elevation in the detail, he collect several the material like a brick and the masonry material around the site. This is a atypical Chinese the ceramic shingle, and then this is also traditional Chinese the brick material. They simply combining everything together to making this unique elevation. So in the detail, you can see there are several different the brick and the masonry material you can find out. So this traditional the loop shingle, ceramic shingle material. This is also loop ceramic shingle, and then that is kind of historical and local brick material. So means they just simply assemble and combining together to propose this unique elevation. Okay. So now where to begin? So where do you begin? What do you consider to propose to your brick assembly? So I just kind of making this category to consider about your brick design. So I think we better to follow this process to understanding about your building type and the brick bond. So you better to understanding about your brick materials. So we talk about what kind of grade for your brick and what kind of colors available on your brick, and then what is about the size, what kind of style, and what kind of texture you might consider for your brick material. And then we also talk about the bond, which is a mortar, what kind of mortar you're using for your project. Okay, so when you just kind of combining the different the grade, color, size, style, texture, and then different mortar type and color, you can making out the unique the brick design by yourself. So let's talk about the brick type. The brick type defined and then determined by ASTM. ASTM is the American Society for the Testing and Measures. So ASTM defined the three different brick types. Okay, FVS and FVX and FVA. FVS is facing brick standard. FVX the facing brick extra control. FVA is a facing brick athletic criteria. So you need to be understanding and have to be memorized these three different brick type. Okay, so let's talk about FVS, the facing brick standard. It is a typical the brick type for architect. So because it is general use, you can using for the interior and exterior, and then it is a wider color and texture available, and it also lots of a different size available when you're using the FVS. This is more about the standard type for using architecture industry. But what is about FVX? So facing brick extra control. This have to be remember about this extra control. What is meaning about it? It is mostly using for the mechanically perfect. So means it is usually using for the mechanic purpose. So you can usually using for the interior and exterior as well. However, it is narrower color and texture range because it is kind of more controlled comparing to the FVS. So means it is called minimum permissible variation in size and permitted. You have to be more accurate compared to the FVS. Okay, so from this region, our industry the FVS is more popular to use. But what about the FVA? FVA is facing brick athletic criteria. The simply understanding about this is more about considering about athletic. So mean it is more about the customized brick. So it means architect determining about your elevation design. Depending on your purpose, you can decide about the size of your brick. You can deciding about the color and the texture. So from the design proposed, you can customize your brick. So when you customize brick, it is the FBA type. Okay, just kind of you have to be understanding about the concept. What is about FBS and FBX and FBA, right? And then the brick also having the two grading. Okay, so the grade SW and grade MW. The SW, it is for the severe weather, and MW, it is the mild weather. Okay, so how you find out that the weather zoning? So you can just see that the map here. The darker gray, it is the severe weather, which is a grade SW, and then the lighter gray, it is the mild weather, right? So it means Iowa, I can say the most of Iowa have to be using the grade SW. The grade SW require the stronger and more permanent brick. Okay, so means when you're using when you're having the project in the central Iowa or eastern Iowa, you have to be using the grade SW brick. Okay, it's not allowed to using the grade MW brick. Okay, so you have to be know about where's your project location and to choosing the grade type for your brick design. Also, brick has the lots of different colors available nowadays. You can choose in the typical red color brick. Also, you can consider about the white color, the gray color, or darker gray, or black color. There are lots of different color options available depending on your project proposed and aesthetic part. You might choosing the brick color for the project. Also, when you're choosing your brick color, you might consider about the two different range, which is the tight range and wide range. What is about the tight range? It has a limited color variation between the module. You can use a very similar color for your brick building elevation. So it means when you wanna give more about the monolithic elevation feeling, you might consider about this tight range. It is about the limited color variation between the module. However, when you want to make more of the dynamic expression of your facade, you might consider to using the wide range. It is extensive color variation between the module. It is more different color between the modules. Okay, so when you choose the brick color, and then you have to be considering about this color range. Wanna give the more monolithic feeling, you might consider about the tight range. But we wanna give the more the dynamic and variety, you might consider to use the wide range. And the brick also having the different size available. So it also different manufacturers, the making the different option. But this one is atypical, the brick size you might consider for your project. But I don't want to ask you to memorize every single dimension, but I just ask you to memorize the modular brick size. This is atypical brick dimension. You have to know about actual number, which is a 3/5/8 inch by 7/5 inch by 2¼ inch. Okay, so this is a modular size. Please memorize this number for the modular brick dimension. So next one, manufacturer type. So brick has three major manufacturer type, which is extruded and handmade and machine mold. Okay, the extruded is most typical type. So you can see the brick column here. Okay, this is unfired brick column, and then so before firing it, so this is simply cutting out by the wire, which is they using some machine, the wiring cutting machine, and then just cutting out this column. Okay, after the brick column extrude out and then cutting out to making this modular size. What about the handmade? Handmade, everything by hand. This old word craftsmanship, so means everything made by the hand. It means each brick has the different looking, right? So it means when you want to make more the variety of your elevation, you might consider using this handmade brick because you can make a more different texture per each individual bricks. What about the machine mold? This is using the mold boxes, and then it's similar as handmade, but it's having the more pressure, so it means top to bottom is pressing it to making out this module. Okay, but just once again, the extruded brick in a contemporary architecture industry, this is most typical type to produce your brick material. So I just gonna bring out the video how this extruded brick is the fabricating in the factory. You just kind of better to understanding about how it works. So next one is brick surface texture. The brick texture, it is very important to decide overall appearance. So identically, the brick can look dramatically changed by simply adding the texture. So there's some variety of the texture available. You can see the vertical texture here, and the smooth texture, and the bark, and rough, and log texture here. And then you can also find that the flash the texture. What is about the flashing? It is one method of firing brick, which burns some of the brick darker by changing the firing temperature. It means it more exposed to the fire, and then higher temperature, it becomes to the darker. So that's why you can make the variety of the brick color. You might consider using the firing hour of your brick. Next one is also pretty important to memorize this terminology. Each brick face has its own terminology here. It is much better to memorize this terminology here, because when you just communicate with the contractor, we have to be using this terminology to communicate with the contractor, because contract is hard to explaining about when you wanna using this brick as the facade and facing. It's hard to explain about this face. That's why we have to be using the terminology for the brick facing. I ask you to memorize the terminology, okay, to understanding and to making the better communication with the other field. So first one, stretcher. This is called as the stretcher, and then when you make it the vertical, it can called as the soldier, okay? And then this side we can call it as the header, but when you're making the vertical out, it is called as the low rock. And then this face, you can call out the sailor, but when you're rotating it, you can call that the low rock stretcher, okay? So please understanding and memorize these terminology, 6 terminology to know about this brick facing. And then now we talk about the coursing. What is about the coursing? This continuous brick layer, you can see the stacking. The brick is usually stacking the layer by layer. The one single continuous layer, it is called as the coursing. It's a course. So it means you can see here, they're using the stretcher facing. So it called as the stretcher coursing. And it is header. You see the header? It is called as the header coursing. And you see here, the soldier, it is called as the soldier coursing. So it means when you just communicate with the contractor, you have to be called header or soldier or stretcher, and then you just kind of ask it to, oh, this line have to be coursing using the stretcher, or you can use header coursing. You have to be using for this layer. So it means it's much easier to communicate with the contractor when you know about this terminology. Okay. Next one, we talk about the joint type. After stacking each brick unit over mortar, it needs the mortar joint tool to making the preferred joint type. So we talk about some disjoint type more next semester, but just kind of depending on the disjoint mortar tool, you can just creating the different types of the mortar between the bricks. So concave here, this atypical the mortar joint type. You just kind of now to know about the concave joint type, and then the next semester we talk about the different the joint type we need to discuss. The depending on the your purpose or depending on the inside or outside, you can choosing the different the joint type for the your mortar between the bricks. However, the concave you can use anywhere. You can use in the inside or outside, and also this is also really good the water protection. So means, for example, when you want to use a lake for the outside, the water is very bad because water usually stay in this location, and then it is usually stay over the brick surface. It means it tends to coming into your assemblage. That's why lake is not using for the outside. But concave here, this is a kind of great. This is the water, and then this water out directly from these joint. So that's why the concave is good for the interior, exterior, any purpose. Now just kind of understanding concave is atypical type for our industry, but I just kind of more interesting about the different joint type next semester. And then let's talk about the bond type. There's for a conventional and typical bonding type you might consider. The running bond, everything made by the stretcher facing. You can see this is all stretcher facing. Okay, and then common bond, you can see the 5 layer using the stretcher, and then the another layer, one more layer using the header. The 5 stretcher and 1 layer for the header. Okay, and then Flemish bond, it's just using the alternating the header and stretcher to making out the building elevation. And English bond, it is using the stretcher for the one coursing, and next layer using the header. So it means coursing, the stretcher coursing, header coursing, stretcher coursing, and header coursing just stacking together. It is called as the English bond. And you can also consider about the different mortar color. The mortar color is also lots of different option. So you can consider about this example here. You choosing the lead brick, but when you're choosing the similar mortar color as the brick, it means you can making out the monolithic looking wall you can design. However, when you're choosing a little bit, you can when you're choosing the contrast color from your brick for the mortar, so it means you can just more emphasize your modular condition here. Same as here, you can choose this brick color, but choosing these similar color as the brick, you can just make it the more monolithic the wall design you might consider. And then, but when you're using the gray mortar with this lead the brick, so you can just kind of more emphasize each the modular design. Okay, so that depending on the elevation scheme, you might consider to choosing the proper the mortar color for the design. Now we talk about the mortar strength. I think that is also very important to understand and to memorize the type. So there is 5 different mortar for our industry. You can see M, S, N, O, K. Type M is the highest mortar compressive strength. So if you need if your brick have to be support heavy weight and have to be sustained the extreme gravity lateral load such as retaining wall, you have to be using the M mortar type. Okay, but you can see the S here. S is the most common, most atypical type of the mortar for our industry. Okay, so it means you can use the S in the basement. You can also use the S is overground. So it is also using for the exterior and interior purpose. So just kind of understanding, M is the highest compressed the mortar type, which is the strongest mortar, which is M. and S is more common type for our industry, and N mortar and S type is very similar, but N type is only above grade. It's not using for the underground, but S can be used in the below grade. And O and K, it is non-bearing wall. It is mostly using for the interior purpose. Okay, just kind of understanding about this one here. O and K is mostly non-bearing, which is the non-structural wall. It is using for the interior purpose. And K is usually using for the historical preservation project. Okay, and N, it is usually N and S is pretty similar, but S is the stronger than N, but S is can using the below grade and above grade, but N is only using for the above grade, and M is the strongest, the mortar type. Okay, so just kind of what you have to be know about what is difference between M, S, N, O, K. So now we talk about the load-bearing wall and veneer wall. I think that is kind of the most important concept for today's lecture. And also, I will talk about the more different assemblage system next semester, how you actually designing the veneer wall assemblage. Okay, but today you have to be understanding about what is about the load-bearing concept, what is about the veneer wall concept. Okay. So load-bearing wall, it is structure purposed wall. Okay, in a historical building, the brick has to be support the building weight. It has to work as the structure member. From this region, the brick wall has to be very thick and then very heavy because it has to be support to the building weight. However, nowadays, the brick is not used as the structure member a lot. We just kind of using the brick as the decoration purpose. So because you usually use the concrete or metal member or timber structure for your structure member. So means the load bearing wall, it requires huge thickness because of this is have to be support to the building weight. And it have to work as the structure member. But nowadays, you cannot use this thick wall for the project because when you use this thick wall, it has more cost for the construction, and then you also losing the loss of the area for your design. So from this region, you have to be considerate about your wall, very efficient, the depth, and the efficient size about your wall design. So that's why instead of using this wall, the brick wall as the structure, you might consider about a different material for the structure member, and then the brick is only for the decoration, which is only for the skin. So when you see this assemblage, this is the metal stud works as the framing of the wall, which is structure member, and then you can also see the interior finish wall, and you can see outside plywood sheeting, and you can add in the insulation. And then between the insulation have to provide the cavity space, which is the air space. And then this brick wall just kind of holding from the metal stud here. Okay. You don't worry about this assemblage right now. We talk about this assemblage next semester again. However, just understanding about the concept, what is different between the load bearing and the veneer. Okay. But you know about what's the difference. Load bearing, it is structural wall. It means it is very thick, and then it has to be support the building weight. But veneer, it is not structure. It's a non-structure member. It is only for the building skin layer. Okay, so just kind of understanding what is different between the load bearing and the veneer system. So now we talk about this project here. I work in this project when I work in San Francisco for the Stanley Seyrovich. This is the Center for Jewish Life in the Philadelphia. We using this brick building because this building is Drexel University in Philadelphia. So their requirement have to be using this lead brick to matching with other university building. But we have to be think about how you can consider to using this lead brick differently, and then how you can make in a more volumetric elevation using this lead brick. So that's why we consider about the different stacking method. So if our brick works as load bearing wall, we cannot making out this undulating elevation because this load bearing wall have to be very thick, and it's hard to making out this elevation pattern. But nowadays we using this veneer system, which is the making by the more understanding about the modular base. It is available to making the various pattern because the brick is made by the modular design. It is easy to making out in and out, rotating it to making out this undulating elevation. So you can see here, so we using this in and out, using this modular brick to creating about this volumetric elevation. So also using the shadow, the casting over the brick facade to designing the brick elevation specially. So you can see the actual construction image. We using the concrete as the main structure, and then you can see the crib here. This is a crib to support the brick. Okay, so after the concrete, we adding the insulation, and then we just kind of consider to adding this brick veneer over this structural wall. Okay, so I just bring it out the building section of this project here. So you can say that is kind of brick veneer layer is non-structural member. The actual structure member, you can see the concrete slab and concrete wall here. Okay, so means you can see upturned concrete beam, and then you can see the concrete slab, and then you can say cover this structure member and adding the insulation, and the brick wall here, it is only for the decoration skin. Okay, it is for the outside layer. It doesn't work as the structure. Okay, so please you don't worry about this assemblage. Now just understanding about the veneer system, which is what is about the veneer system. It's non-structure. It is only for the skin layer. Okay, just kind of understanding what is difference between the veneer system and the load bearing system. I think now it's kind of interesting chapter, the new brick assembly method, how we understanding about this brick material and how we using this brick in the contemporary architecture industry. The first brick type, it is precast brick panel using the digital fabrication. It is a 290 the Mulberry, New York City, designed by the shop architect. When you see the project facade, the brick is interesting to making this undulating brick elevation. I think that is very difficult to making out this brick stacking, the module by module. It is hard to making out this undulating elevation. So from this reason, architect consider using this digital fabrication. It looks like the individual brick module. However, they creating the panel itself. So means they designing the whole panel. Okay, I say just sketch over. So they designing about this whole single panel, and they also making this one single panel using the concrete. So it looks like a brick, but they using this precast concrete to making out this panel. So this is a kind of process. So that mold made by the CNC, the milling machine, then they just pouring the rubber, which is pouring the rubber over it to making out the reusable mold. And then they just kind of pouring the precast concrete to making out the individual the module and individual panel. But when you see this individual panel, it looks like a brick assemblage. So they just kind of creating the prefabricating this panel in the factory, and then simply deliver this panel to the site and assemble this prefabricated panel to the location. So now we talk about the robot, the brick assembly. The I just bring it the one video. It is the brick assembly robot arm. Using the roboting method, you can design any kind of architecture form as design inspiration. The robot is kind of introduced, and then nowadays architecture industry, the start using the robot a lot to designing about the elevation, also to designing about the lots of different the way to expressing about the architect the inspiration. So let's watch this video together and then we can jump into the next topic.
There's a kind of an almost emotional response to a robot. You know, there is this kind of idea that a robot is a sort of an artificial human. But of course, all the other things that make architecture what it is are the things that come, you know, beyond the mechanical, beyond the sort of, you know, automated. And what Gramazio and Kohler are doing in Zurich that's really fascinating to us is they're breaking away from the idea that a robot is there to do menial, repetitive tasks. And they're intervening in that world of being able to program what the robot does. And in a way, they're kind of using it as an extension of their own bodies, their own tools, and changing what it does as it moves along. The robots have been around for the good part of 90 years. They really got going in the 1970s, the 1980s. And there are more sophisticated robots than this. But the fact that they've been brought into an environment where they've been used as design tools is the exciting thing.
Now that the tools, both the hardware and the software, are becoming more affordable and easier to use, architects are actually being able to start to use the same kind of tools that have been out of reach for so long. So yes, it's only the beginning of things, but we really see some opportunities in design and fabrication. They won't necessarily build whole buildings, but this country does have very old building stock. We literally need to retrofit thousands of buildings every day to meet up with demand. And so it's certainly worthwhile considering how these kind of technologies can work alongside traditionally skilled labour to actually be able to keep this country's buildings up to the standard that they need to be.
What we're looking at now with these technologies is we can bring them into the academic environment, and students and academics can in effect experiment with the idea of building, the idea of making. I think that opens up a very exciting new domain for universities. It might be that we are starting to be regarded potentially as a place to prototype things that might not be prototyped elsewhere. We can carry a certain level of risk that the commercial world can't carry, in the sense that research that fails is very valuable, but in the commercial world it's obviously a very different scenario. So I think this technology opens up not just something for architects, but for universities across the whole built environment sector, and allows us to do things that can't be done elsewhere.
Okay, and also in the field assembly, also they have a considering about the nomadic idea. They can actually transport this robot arm any construction site. So this robot arm can construct and assemble anywhere using this transportation system. You can see that they are put the mortar over the brick surface, and then they simply place the light direction and the light place. Okay, and then also you can see this robot, the brick layering. This robot name is the SAM. It is the semi-automated mason. The robot consists of standard 6-axis industrial robot arm. 6-axis means they can have a Z-axis, X-axis, and Y-axis. It means robot arm can move anywhere. They use the 6-axis industrial robot arm, mounted to a conveyor belt. It picks up each brick and covers the side with a mortar and place it next to the last brick. But Sam can lay bricks 3 times faster than normal bricklayer from the human labor. is much faster than the human labor. However, this SAM, the robot, it still need a human mason following the behind to clean up the mortar. You can see the robot itself, they cannot clean up the mortar. So means the human labor always follow to clean up this mortar. Okay. So using the robot, so now it is more about the dreams come true from the architect, the design, the direction, and then design proposal. So this robot arm is making out this undulating, and then it looks like a pretty impossible the making of this undulating the surface by the human labor, but the robot is available to the making out of this the new possibility for our design. So next is kind of an example about the BioMason. I think the BioMason is also interesting concept. The BioMason has developed a technology using the microorganism to grow the biocement, the based construction material. So means it just looks like more about like a mushroom looking. They are actually growing the mushroom like a brick. It means their proposal is kind of reduce the CO2 emission, because when they making the brick in the factory, they have a lots of CO2 emission. Also after the fabricating the brick, and then this brick have to be transported to the construction site. It also lots of CO2 emission. That's why their idea, they want to making out the brick on the site. It means they actually growing the brick on the site and using this brick to the actual construction. So let's watch this video together, and then how architect and engineer or biologists, they just kind of making out the new types of the material from the conventional and existing material. Okay, let's watch this video together, and then I just kind of show the project using this BioMason material.
Global building construction is responsible for 30% of all greenhouse gas emissions. An estimated 1.23 trillion bricks are manufactured every year, resulting in approximately 800 million tons of carbon emissions due to the fossil fuels required in the firing process. Organisms like coral form a durable cement at ambient temperatures and without destroying their surrounding environment. At BioMason, we have developed a technology that uses microorganisms to grow bricks as a market-viable green alternative to traditional masonry. Our protected process employs natural bacteria to form a durable cement between grains of sand. Nutrient and minerals required in the process are obtained from natural, renewable sources, but may also be extracted from industrial waste streams. Unlike traditional clay and concrete products, which contain a high embodied energy, biocement forms in ambient temperatures and without the use of fossil fuels, requiring only 5 days to produce a hardened brick comparable in strength and cost to a commercial unit. BioMason has received numerous international inquiries from architects and builders who wish to specify BioMason bricks. Our objective is to place BioMason's technology in the hands of existing masonry manufacturers across the globe. By capitalizing on the benefits of distributed manufacturing, BioMason licensees will use closed-loop mobile production modules with BioMason biocement to produce bricks on-site from indigenous raw materials. Seed funding from the North Carolina Biotechnology Center and the Cherokee McDonough Challenge have enabled BioMason to achieve significant development milestones. Starting with a better brick, the BioMason team and partners are working to build a better industry.
So using this concept like a BioMason, the MoMA PS1 David Benjamin, he proposed this BioMason material for the pavilion design. So this is the previous one using the microorganism, but this one is actually using like a mushroom kind of organism to making out this brick. Concept is same. They just growing this brick on the side, and then using this brick for making out this pavilion design. Today I just introducing about what about the concept about the brick, and then how you can making out your own brick basically from the different the brick consideration. Also we talk about the load bearing wall assemblage and the veneer wall design assemblage. I think it's a very important concept to understand. And then we also talk about how you consider to using the brick in the future. So you just kind of understanding about your age, how you understanding about the existing brick elevation, and how using this brick elevation as your design differently. And also we think about how you can use this brick in the future. So hopefully you guys are understanding about this kind of a concept about the brick and concept about the masonry material. And then I'm more interested about the assemblage and the detail the next semester. Okay, so let's watch the last video to talk about the BioMason, the mushroom brick tower project in MoMA PS1. I think that is kind of pretty fascinating to see the construction process and also see the vision about the new masonry project. Okay, let's watch this video together.
We can try to do things differently. We don't have to accept the ways that buildings are always designed. Like all of our projects, we imagine this as kind of a test or a prototype for the architecture of the future. At The Living, we've been experimenting with bringing architecture to life through actual living biological organisms and having those somehow participate in the act of designing and making new structures. MoMA PS1 is very interested in sustainability and new approaches for architecture. So I think we were interested in saying, could we create a new material and a new kind of ecosystem of design and manufacturing and construction that was sustainable in new ways, that kind of pushed the limits and tested the limits of what sustainability could be. Hi-Fi is basically 3 cylinders or towers that branch into each other and create a kind of endless loop rising up from the courtyard of MoMA PS1. It creates a kind of new and captivating environment for the summer warm-up events. But in addition, it's an experiment in a new paradigm for design and manufacturing architecture. Hi-Fi is a reference to a kind of technical term called hyphae, which is the type of living organism that we use to manufacture the building blocks of our project. In this project, we're using a living organism as a factory. So the living organism of mycelium, or hyphae, which is basically a mushroom root, basically makes our bricks for us. It grows our bricks in about 5 days with no energy required, almost no carbon emissions, and it's using basically waste, agricultural byproducts, chopped up corn stalks. This mushroom root fuses together this biomass and makes solid bricks, which we can kind of tune to be different properties. So stronger or more flexible, more water resistant, and then are using it as a factory to manufacture, the building blocks of architecture. One of the things that we're experimenting with in the project is a kind of local economy of materials. Everything from the project in its entire life cycle comes from a 150-mile radius. And then at the end of the lifespan of the temporary structure, we're going to compost it, again, right here in New York City, and return that raw material to local community gardens and tree planting. So in that sense, we're experimenting with a local version of architecture, similar to some experiments with the local food movement. And we think that's, an interesting model for architecture in this age of globalization, where typically materials, especially raw materials for a building, come from all over the world. We're saying, actually, there's some scenarios where we can have just a very local economy of materials and energy, a local footprint. We designed the project first in the computer. That allowed us to quickly explore a lot of different shapes, but then we also have to decide, how to lay out the bricks. We would pass off some of the geometry of the project to the company that's manufacturing the bricks. Then after the bricks are grown and tested, we get test results of crushing these bricks. We send that data to the great structural engineers at Arup. They analyze the structure, give us the results. We take that back into our 3D model, revise the overall form, the centerline model, and then rerun the algorithms that lay out the bricks in the most efficient way. It's really an important loop for us to do many times in order to get all of the factors right, to make this structure that's both new and experimental and testing something innovative, but also safe and able to withstand hurricane winds and the sun and rain of New York City summers, and the wear and tear of people having giant parties in the courtyard of PS1 inside it. Each architecture project is, of course, different and with its own challenges, but probably almost all architecture projects should provide function like shelter, durability, like interesting spaces to do things in, but also it should provide atmosphere, interesting environment to be in, interesting qualities of light and space. And with the added issue of sustainability, there are kind of further challenges and constraints, but it often adds opportunities. The constraints make you think again about the way things should be done, and in some cases force you to be more creative. If people can take away the idea that new possibilities can be imagined and then brought into the world and tested, and we can learn something about them and then kind of take it to the next level afterwards. We hope it can be some message or inspiration in that way.